go from there. All right. So again, 4.1 covers polynomial functions and zeros. First off, to get to a polynomial function, we've got a couple of definition things we need to go over, and the first of which is a monomial. A monomial is a singular term. So a monomial is also referred to as a term and is any combination via multiplication of just a number. That's an example of a monomial. Or just a variable, or some kind of multiplication of those. And you can use exponents or not. If you don't see an exponent, it's an exponent of 1. There's a power of 1 here. If you don't see the exponent, and if you don't see the variable, then it's a power of 0. But anyway, just a number represents a term. Just a variable represents a term, or some multiplication of those, like 3 times x squared, or negative 1/2 xy cubed, or x squared y cubed. Each of these are examples of a monomial or a term. Now, within an individual monomial, the number in front of the exponent is referred to as a coefficient. C-O-E-F-F-I-C-I-E-N-T, if you can't read my crappy handwriting. Okay, a number being multiplied to a variable is a coefficient. And this power is going to be the degree of the term. Now, if you have just an x here, there's a couple of implied numbers. For example, if you don't see a number in front of the x, it's like saying 1 times x. So the 1 is implied to be your coefficient. Similarly, if you can't see an exponent, it's to the power of 1. So that would be your degree. So just a variable of x has a coefficient of 1. Just a variable x has a power of 1. Or it would then have to be x. The variable could be y or z or a or whatever. Okay. Now, if you just have a singular number with no variable, this is referred to as a constant. Variables change, numbers are constant. It doesn't change. So because we're not multiplying any variables that can change, this thing will never change. This is always worth a value of 5. This is worth a different number based off of what your x is. If your x is 0, this whole thing is worth 0. If your x is 2, 2 squared is 4 times 3 is 12, this whole thing would be worth 12. So this number varies because of the variable. With no variable, this is a constant. It'll always be 5. Okay, so again, vocabulary, just a number is a constant. If you have a variable, the number in front is your coefficient. If you don't see it, it's a 1. Your power is basically going to be your degree. If we have a problem like so, okay, that negative 1/2 will be our coefficient. And if you have multiple powers, we can add those together to get our degree. So this one would have a coefficient of negative 1/2, and then this 2 plus this 3 is 5, so that would give me a degree of 5. Now, again, we're going to be talking about polynomials. A polynomial is simply a combination of terms via addition. So if these are all monomials, then a polynomial will combine these. For example, 3x squared plus 5 is an example of a polynomial. So as long as you're combining terms via addition or subtraction, then you have more than one term. That would be a polynomial. A polynomial is more than one term. So that says more than one term combined by addition or subtraction. For example, 3x squared plus 5, or 4x cubed minus 2x squared plus 3x plus 1, or some kind of nonsense like that. Okay, as long as you have more than one term, you have a polynomial. Now, polynomials also have a couple of definitions we need to talk about. Typically with a polynomial, we write them in order of decreasing degree. So you want the biggest exponent to the front, and then as the exponents get smaller, that's how we would write them. We write them in descending order according to the exponents. Okay, now I picked numbers that kind of go in this order, but the fact that the 4 is the biggest doesn't matter. It's the fact that the 3 here, this power of 3 is bigger. That's why we put it to the front. Now, this here is what we call our leading term. And this is the one that we really kind of want to focus on. So this 4 is called our leading coefficient. And this 3, because it's the biggest degree, that would be the degree of the whole polynomial. So each individual term has a degree, and then the degree of the whole polynomial is just that biggest one. So in other words, my leading coefficient would be the 4. The coefficient of the leading term, the one with the biggest exponent. Okay, and then the degree of the whole polynomial is simply the biggest degree of the polynomial. So this one has a degree of 3, this one has a degree of 2, this has a degree of 1, this has a degree of 0. The biggest degree is the degree of the whole polynomial. The first couple of questions in your homework ask you that kind of thing. It's like, what is the leading coefficient? What is the degree of the whole polynomial? Okay. Also, when it talks about degrees, don't confuse it with this even and odd functions, but this would be an odd degree polynomial. So because the leading or the biggest degree is odd, that makes this an odd degree polynomial. So if we just had something simple like x to the 4th minus 2x, again, in descending order according to degree, this particular one has a degree of 4. If you don't see an exponent, it's a 1. So this 2x, negative 2x, has a degree of 1. So this is my biggest one. So as far as the whole polynomial is confirmed, the leading coefficient would be the coefficient of this x to the 4th. And remember, if you don't see a number in front, it's a 1. So this would have a leading coefficient of 1. And then the degree of the whole polynomial would be the 4. Okay, the 4 is the biggest degree within the polynomial. So that would be the degree of the whole thing. Now, another thing that will help you as far as this goes, this degree of the polynomial will also classify the polynomial. If you just have a number, this is referred to as a constant polynomial. The graph would just be a straight line. If you have an x to a power of 1, this is referred to as a linear polynomial. And on an XY graph, it's going to be some sort of slant. It can go up and to the right or it can go down to the right, but it's always going to be a straight line on some kind of arc, or not arc, but some sort of angle, some sort of slope. Constant will always be horizontal. A linear term will go up or down at some angle. If you have an x squared, this is called a quadratic. And a quadratic will always make some kind of parabola. If you have an x cubed, that's called a cubic function. A cubic function will go kind of down and to the left, okay, kind of go up and to the right, like so. And then the last one we're going to mess with is a x to the fourth power. This is called a quartic function. If you graph this, it kind of makes a W looking graph. So again, that leading degree defines what kind of function we're dealing with. Okay, and again, just a number is a constant function. It's the graph of a horizontal line. X to the first power, just an x, is a linear function. You'll have a straight line going at some kind of angle, up or down. Again, an x to the second power is a quadratic. It makes a parabola. X to the third power is a cubic function. So similar to a parabola, but this one goes down compared to this one going up. Okay, next to the fourth power is a quartic function. It ends up graphing kind of like a W. Again, the first couple of problems in your homework are going to just present you with some kind of polynomial. And it could ask you a couple of different questions. Primarily, they'll stick with what is the leading coefficient, what is the degree of the polynomial, and then classify the polynomial. In those particular cases, for this particular function, the leading coefficient is again the number in front of the term with the biggest degree. And if you don't see a number again, that would be a 1. So this one would have a leading coefficient of 1. The degree of the whole polynomial is the largest degree within the polynomial. So that would be the fourth power. So that would be a degree of 4. And because this is an x to the fourth, this would be considered a quartic function. So if it was a squared, it'd be a quadratic function. If it was a cubed, it'd be a cubic function. So that's the first couple of things they're going to ask you within this. It's a lot of classifying. So this is kind of a vocabulary heavy lesson. All right, from there, they're going to also kind of discuss end behavior. So you're going to have to match the graphs of some of these functions. And that's really kind of the focus of next section. But one thing we're going to talk about here is end behavior. So end behavior relates to the graphs of the function. If the biggest degree, or the degree of the polynomial, if the degree is even, your ends are going to go the same way. For example, if we had a positive, whatever, x to the fourth plus 3x squared plus 2, or something along those lines, okay? We have an even degree, and it's positive. Your end behaviors are both going to go in the same direction, and if it's positive, they're both going to go up. Now, the interior of the graph could do a bunch of different things, but again, we're just talking about the end behavior. So specifically, what does the end of the graphs do? So with an even degree, they're going to go in the same direction, either both up or both down, and that's based off of whether this is positive or not. So if we would have had a negative x to the 6th power, yada, 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 plus x to the 4th minus x cubed plus 2, some kind of nonsense like this, the fact that this is negative says my end behavior, they're both gonna face down. Now, again, the interior of this graph could do any kind of goofiness, okay, but the ends are both gonna be facing down. So again, with an even degree, my ends are gonna go in the same direction. If they're positive, they're all gonna go up. If they're negative, they're gonna go down. An odd degree polynomial, like an x cubed, they're going to go in opposite directions. So it's going to go like so. If this is positive and odd, the left side will go down, the right side will go up. If it's negative, so we'll say we have a negative x to the 5th plus whatever, x squared plus x, something like that. Anyway, a negative odd degree polynomial, the left side will go up, and then the right side will go down. So again, this is just discussing what the ends are going to do. So if you don't have to be really specific with the graph, and in fact, a lot of the problems that you're going to do are going to be matching, and because they're matching, sometimes just knowing the end behavior of the graph is enough to determine which function we're looking at. And I'll show you some examples within the homework. I'm also going to show you one thing you can do to double check. Desmos, I'm going to show you that website again. Desmos is a wonderful graphing utility, and I'm actually going to use it here in just a second to illustrate more along these end behaviors. So if I share my screen, this should play right. So share, I want to go to, not that one, go to that one. Okay. And again, if we just type in Desmos, DESMOS.com, that should bring up my graphing utility. This is free, it's online, doesn't cost you anything. You want to go into the graphing calculator, and then you can literally type in any function you want and it'll graph the whole thing. So we can type in whatever, and if I pick an even powered function, okay, the more stuff I add is going to change the middle of these graphs. But if you look at the ends, what I have is a positive even powered polynomial, so my ends both go up. Now again, the more stuff I add to this, that's going to change what this graph does here in the middle. But if you still look, the ends are still both facing up. And to change that, if I simply put a negative in front of this x to the 6th, that's going to flip the whole thing over. And now my ends are facing down. Okay, so the middle part is determined by all this other nonsense. Okay, this leading term here is what determines my end behavior. So again, the fact that this 6 is a power or an even power, my ends are going to go in the same direction. If it's negative, they're both going to go down. If this is positive, then they're both going to go up. And I can delete this x to the 6th. And if you look this x to the fourth, okay, same thing. We still have an even power. And as long as it's positive, both of my ends are going to go up. If I were to turn around and make this negative, again, both of my ends go down. If this is an odd powered function or polynomial, like an x to the cubed there, okay, then you see we go in opposite directions. A positive odd polynomial is going to go down to the left, up to the right. And again, if we make that negative, it flips the whole thing over and we go up to the left and then down to the right. So again, positive odd polynomial goes down to the left, up to the right. So again, just knowing that end behavior is going to allow you to match up a bunch of the graphs. If you need specific points, then again, we can use a graphing utility and we can graph each of these individual specific points. It's kind of cool how Desmos can just kind of graph whatever the heck you want to type in here. You can type in anything and it'll graph it. But if we go in, let's see, I want to stop sharing. Ooh. Sorry, I am going to want to share here in just a second, but I want to make sure I'm on the right screen. I want to look at, I got logged out. Sorry, I'm going to share my screen in just a second. I'm trying to open up a web page. If you'll give me 1 second, because again, I want to show you within some of these problems just how easy it is to match based off of your end behavior. All right, hopefully you can see this problem on my screen. It's showing, okay, for the function f of x equals 1/3 x to the second power minus 4. Okay, use the leading term test and knowledge of y-intercepts to match the function with the graph below. All right, so again, if we're just looking at this particular function, I'm going to try writing on my screen. Hopefully this records. Hopefully you can see this. But if I'm looking at this 1/3 x to the second, that's going to kind of determine exactly what we're talking about here. So if I just look at that piece, okay, x squared. So 1/3 x squared minus 4. X squared is an even degree. And the fact that this 1/3 is positive tells me my end behavior is going to be like so. So both of my ends are going to go in the same direction. So that cancels out B and C. And if that 1/3 is positive, then both of my ends are going to go up. So that cancels out D. So my only choice in this case is going to be A. So if I clear this out, okay, and I pick A, that's going to be the correct answer. So all you're going to need for some of these is really just knowing that end behavior. Okay, kind of along the line, same type of function here. Now we have an x to the 5th power. Because that's an x to the 5th, that's an odd degree. So that tells me my end behavior is going to go in different directions, and a positive odd is going to go down to the left and up to the right. So B, they're both going down. That's not going to be it. C, the left is the one going up and the right is the one going down. That's not going to be it. Just knowing the end behavior tells me that, again, A is going to be the right choice. So again, the left goes down, the right goes up. That shows A should be the correct choice. So again, if I clear all these out, cut that out, A, and there you go. So that's what end behavior can do. So if you're given a graph, you should be able to match the function just almost based off of what the ends are doing. Now, if the ends are going in the same direction, I can show you some other ways that we'll be able to match it up. But like I said, that's more about 4.2. All right, so we'll stop sharing and we'll go back to my handwritten notes. Okay, so again, end behavior. Even polynomials, the ends go in the same direction. If they're both positive, your ends are both going to go up. If it's negative, your ends are both going to go down. Odd polynomials, like an x to the third, x to the fifth, x to the seventh, x to the ninth, they're going to go in different directions. Again, a positive is going to go down to the left, up to the right. A negative is going to go up to the left, down to the right. All right, the last thing we're going to talk about within 4.1 are these things called zeros. Let me get a different color, I'm sorry. Zeros. Zeros have a couple of different ways to look at the function, or basically they serve a couple of different purposes. Typically, when you're trying to solve a function, this is what we're looking for. So a zero is specifically a value for x that makes the whole function f of x equal 0. So each of these things that we've been talking about has been some function of x, like so. So any number I can plug in for x that makes this whole thing equal 0 is a 0. For example, if I told you to find the f of -2, that means to plug -2 in for x. So if we plug that -2 in for my x's, -2 to the second power is +4. 3 times -2 is -6. And 4 minus 6 plus 2, so 4 minus 6 is -2, -2 plus 2 is 0. So because that number makes this whole thing equal 0, then -2 is a 0 for this function. I guess that should say of the function. So -2 is a 0. So again, plugging -2 makes the whole thing equal 0, so it therefore is what we call a 0. Now, that's by definition what a 0 is. In terms of the graph of the function, if we were to graph x squared plus 3x plus 2, x squared is a parabola. This isn't 100% accurate, but it's going to be some kind of graph that's going to do that kind of thing. Okay, your zeros are where your graph crosses the x axis. In this case, that would happen at -1. That would also happen at -2. This particular function has two zeros that occur at -2 and -1. We just showed -2 is a 0. We could also do the same thing. If I plug -1 in, -1 squared is 1. 3 times -1 is -3. 1 plus 2 is 3 minus 3 is 0. So again, -1 and -2 are your zeros. If we were to accurately graph this function, it would cross at those two places. So a 0 can also be referred to as an x-intercept. It's where your graph is going to cross the x-axis. Okay, so a 0 makes the function equal 0, and it also shows where you cross the x-axis. Another neat thing is if you look at that leading degree, this tells you how many possible real zeros there are. So the fact that this was an x squared means we have the potential for 2 zeros. Okay, so similarly, if we had an x to the fourth function, the fact that this is in fourth power tells us that we could have a maximum of 4 zeros, which makes sense again if we talk about end behavior. Okay, a fourth powered function would look something like that. So at most, we're going to have 4 zeros. Now it's not a guarantee because you can have a couple of different things happen. You can actually have a graph that would do something like this, where you would only get 2 real zeros. And then we'll talk about this later, but this would actually give you 2 imaginary zeros, which we can talk about that. Also, if the graph did one of these things where, say, it bounced off of the x-axis, you would actually only get 2 real zeros. This is a repeated 0, and I'll show you kind of what causes that. But anyway, the degree of your function tells you the maximum number of possible real zeros. So a fourth powered function has at most 4 zeros. A cubic function would have at most 3 zeros. So again, that leading degree gives you the number of possible real zeros. Power of 4, 4 possible real zeros. Power of 3, 3 possible real zeros. Okay, like we showed you on the parabola. Go back to our previous notes. Power of 2, 2 possible zeros. So the trick is finding those. Sometimes they're just going to ask you how many possible zeros there are. Sometimes they're going to give you a factored form of the function. So instead of writing it as a polynomial, so instead of saying something like f of x equals x cubed minus 2x squared plus 2x plus 1 or some kind of nonsense like that, they could write a completely different function. They could write it as a product of factors. If it's written this way, this actually makes it really easy to find the zeros, because basically anything that would make this one equal 0, that would be a 0. Same, anything that would make this equal 0 is a 0, and anything that would make this one equal 0 is a 0. Now, also written in this way, well, if we solve these, I'll come back to talk about what I want to talk about. X plus 1 equals 0. If we wanted to solve this, subtract 1 from both sides. X equals -1, so -1 is a 0. Subtract 2 from both sides, okay, X could equal -2, so therefore -2 is a 0. X plus 3, subtract 3 from both sides, X equals -3. -3 is a 0. Now, this, lost my red pen. Okay, this second power means this X plus 3 happens twice. This is called a multiplicity. And what that simply means is this -3, while it is a 0, it's going to be a 0 2 times. So if you think about this, we've got 1, 2, 3, but the fact that it's squared, this is a fourth powered polynomial. So this should have 4 zeros. So the -1 is 1, the -2 is 1, and the -3 is 1 is also 1, but it happens twice. So this would actually count as 2 zeros of the function. And what happens when you have a multiplicity, if it's an even number, the graph is going to do that thing where it bounces off of the axis. So without even knowing exactly what this function would look like graphically, I know a couple of things, and we're going to show this. I'm going to go to Desmos and prove it. But this X plus 1 times X plus 2 times X plus 3 squared, here's some things that I know about this particular function. Number one, I know that -1 is a 0. I'm going to hit the x-axis at -1. I also know that -2 is a 0. And I also know that -3 is a 0. Okay. The fact that this is all positive, and again, there's 4 x's, 1, 2, and there's 2 of those there, so 1, 2, 3, 4. So this is a fourth powered polynomial that's even. That tells me my end behaviors are going to both go up. So my end behaviors are both going to go up. The fact that this -3 is twice, that means I'm going to bounce. I'm not going to go through the x-axis. I'm actually going to bounce here. My graph is going to look something like that. Now, this piece in between, I don't know exactly how far this goes up. I don't know exactly how far this goes down. But just based off of my zeros and the fact that this is a multiplicity, I know some things about this graph. Again, I can tell you my end behavior. I can tell you I'm going to bounce. I'm not going to go through the axis here because I have an even multiplicity, but I am going to go through the x-axis on my other 2 zeros. So if I were to take Desmos and graph this function, it would look something like this. So again, if I share my screen, here we are, go to Desmos. If I type that function in, so x plus 1, x plus 2, then x plus 3 quantity squared. Okay, if you look, that looks a lot like my graph. I know my ends both go up. I know I bounced here at -3. I did not go through the axis. I hit it and then went right back up. I did go through the graph at -2, or through the x-axis at -2, and then I go through the x-axis at -1. Try and draw on this and hopefully it counts all that. But again, my end behavior was the same. So I know that my ends both go up because again, this has 1, 2, 3, 4 because it's a multiplicity here. Okay, I've got 4 x's. That makes it an x to the 4th. even positive polynomial tells me my end behaviors are both going to go up. They both go up. Okay. My zeros are -1, -2, and -3. So -1, -2, -3. Because I have an even multiplicity, then I'm not going to go through the axis. I'm going to bounce there. Okay. I could do the same thing. So if I just make up a function, close this. Okay. And let's say x minus 5, x minus 3, x plus 4. And we'll do another one, x plus 1. Okay. And we'll just square this one. We'll cube this one. All right, so that makes for a really crazy looking function. But again, each one of these represents a 0. So if x minus 5 is a factor, then 5 is a 0, because 5 minus 5 is 0. So my zeros, let's see if I can write on this. Okay, so again, x minus 5. Okay, that means 5 is going to be a 0, because 5 minus 5 is 0. So there's one of my zeros. And right there at 5, I get a 0. I'm going to cross. Okay, x minus 3, that means I have a 0 at 3. And again, the fact that this is an even multiplicity means I'm going to bounce. So at 3, we don't go through, we essentially bounce. And if I would zoom in, like it looks like a point, but if I zoomed in, you can see that you're going to get a rounded bouncing here. Okay, x plus 4, that means -4 is a 0. X plus 1, that means -1 is a 0. The fact that this is odd, we're not going to bounce, we're still going to go through, but you're going to see there's kind of a curve as we go through. But anyway, that tells me where my zeros are. Now again, looking at my x's, I've got 1, 2, 3, 4, 5, 6, 7. So I've got 1 here, 2 here, 1 here, and 3 here. So 7 x's, this is an x to the 7th power. Again, they're all positive. The x's are anyway. Don't worry about the minuses in here. Positive x, positive x, positive x, positive x. Positive x to the 7th means I'm going to go down and to the left and up and to the right. And if we zoomed this graph out, this goes this way, and this would keep going this way. At some point, you're going to get some kind of curve where that would go there. If I would zoom out, you would be able to see that a little better. Get out of this. I think I can do that. So if I zoom this out, never mind. It's going to have to be zoomed way too far out to be able to mess with that. All right. So that talks about factors and finding zeros. And then again, those multiplicities, if you have an even multiplicity, that just means your graph is going to bounce off of the x axis. So again, if we zoomed in on that particular function, so if that's -3, that's -2, that's -1, again, we're going to bounce on the -3 because it's an even multiplicity. If there's just 1, or if it's odd, then you're actually going to cut through the x-axis, like so. Now, the hardest thing we're going to have to do within this particular unit, or this particular section, is if they don't give us the zeros, but we have to find the zeros. If they don't give us the zeros, but we have to find them, we're going to have to use something called factoring. So real quick, I'm going to just kind of discuss factoring, and we're only going to have to worry about essentially 3 different kinds of factoring. Factoring out a greatest common factor, factoring by what I call unfoil, and factoring by grouping. The easiest one is the greatest common factor. An example of this, so if they give us a function like So and they tell me to find the zeros. So I'm trying to figure out what numbers I can plug in for x that are going to make this equal 0. I could go to Desmos, graph it, and do that, but the bad thing is I can't use Desmos on my test. So I'm going to show you the method that I want you to use. And again, we're going to factor. So the first thing I'm going to look for is a greatest common factor. Is there any one thing I can factor out of both of these terms? And if we're looking, they both have an x, and I can factor out the smallest exponent. So in this particular case, I can actually factor out an x to the third power. If I divide this x to the third out, x to the fourth leaves me with 1x here, negative 3x cubed, that leaves me with a negative 3 here. So to find my zeros, I simply set my factors equal to 0 and then solve. So x to the third power is 0 only happens when x is 0. X minus 3, if we add 3 to both sides, then x equals 3. So what we determined is by factoring this x to the fourth minus 3x cubed, again, x to the fourth tells me I should have 4 zeros. And that's what I have. Okay, this x cubed represents 3 of the solutions. This is a multiplicity, so that means I get a 0 of 0 with a multiplicity of 3. And then I get 1 0 at 3. So again, one way we can find our zeros is to factor out a greatest common factor, and that's going to be the easiest ones that we'll have to mess with. Okay, factoring out a greatest common factor, you're basically just dividing out, something you can divide out of both of these. In this case, they're both divisible by x. I'll do another example, and then I'll go and do one of those others. So under the same category here, so a greatest common factor, if we had, let's do 4x squared plus 8x. Okay, again, if I want to factor this, I'm looking for what I can divide out. So looking at 4x squared and 8x, those are both divisible by 4x. So if I divide that out, 4x squared divided by 4x is just x. 8x divided by 4x is 2. So my factors are 4x and x plus 2. So if I set those equal to 0, divide by 4, I get a 0 at, again, 0. Subtract 2 from both sides, I get a 0 at negative 2. Again, this is a squared function. I should have 2 zeros. I got 2 zeros. So that's an example of solving or finding my zeros based off of greatest common factor. Most of the problems you'll do are going to be an example like these. I call it unfoil. It's basically factoring a trinomial. The easiest way to do these so say we had x squared plus 4x minus 12. If we want to find the zeros, we've got to factor this. To factor a 3-termed polynomial, okay, again, we're going to do what we call unfoil. So what can we multiply to get x squared? Just x and x. And then the trick to this is we've got to find 2 very specific numbers. I need these 2 numbers to multiply to get negative 12, but I also need those numbers to add to get 4. So I've got a bunch of numbers to choose from, but I'm looking for very specifically the two numbers that will multiply to get -12 and then add to get 4. Now, some people are really good at this and they can see these numbers. In fact, they already know the answer before I even say it. Others, I'm going to just kind of walk you through step by step. I'm going to start with the multiplying because in terms of what I can add to get 4, there's too many numbers. I can add 1 plus 3, 10 plus -6, 100 plus -96, okay? I can add a bunch of different numbers to get 4. But if I'm talking about numbers I can multiply to get 12, okay, that's a smaller list. Multiplying to get 12 is going to be 1 and 12, or 2 and 6, or 3 and 4. And that's pretty much it. Okay, not counting fractions, but we're just dealing with whole numbers here. And to be a -12, I need one of these numbers to be negative. So -1 and +12 gives me a -12, -2 and +6, -3 and 4. Now I could have made these negative, it wouldn't matter. I just picked the ones on the left. But now, like I said, I'm specifically looking for a pair that's going to add to be 4. So -1 plus 12, nope. -3 plus 4, nope. But -2 plus 6 is 4, so that's what I want. So I've got -2 and +6. That represents these factors. So x minus 2 times x plus 6 would equal this if we would FOIL it out. Anyway, if we continue, x minus 2 is equal to 0, x plus 6 is equal to 0, add 2 to both sides, subtract 6 from both sides. That would be my zeros. And again, if we wanted to, we could graph this using Desmos, okay, and that would show you where you were crossing. But in this case, we're going to solve by factoring. And again, this is for finding the zeros of a function. We'll do another one of those. Okay, again with 3 terms, so we have x to the 4th minus 10x squared plus 16. So again, we have a 3-termed polynomial. We need to find our zeros. So we're going to solve by factoring. X to the 4th would be x squared times x squared. Now again, I'm looking very specifically for 2 numbers. My 2 numbers need to multiply to get 16, but they also need to add to get -10. So 16 is 1 times 16, or 2 times 8, or 4 times 4. Now, these need to multiply to get a positive, so the 2 positives work, but those don't add to get a negative number. So in this case, I need both of these to be negative, because a negative times a negative is a positive, but then a negative plus a negative is going to yield my negative answer. And in this case, again, it's the middle one, -2 and -8. -2 plus -8 is -10. -2 times -8 is your positive 16. So those are my factors. Set those equal to 0, add 2 to both sides. Now, to get rid of the squared, we have to square root. And we also have to count for the positive and the negative. Whenever you square a number, you're taking it times itself. So a positive times a positive is a positive, negative times a negative is a positive. So you have to count for both. Add the 8 to both sides. Again, to get rid of the squared, we got to square root. So x could equal plus or minus the square root of 8. One thing that should help you with remembering the plus or minus is, again, this degree. This is a 4th degree. I should have 4 zeros. So I get a positive square root of 2. I get a negative square root of 2. I get a positive square root of 8. And I get a negative square root of 8. So again, this represents all 4 of my zeros. Now, like I said, these are the hardest questions within this unit. Most of this unit is matching stuff. What is the end behavior doing? What's the leading coefficient? What's the degree of your polynomial? All relatively easy questions. These are going to be the trickiest ones where it just gives you a function and tells you to find the zero. Again, if you get hung up here, you can just go to Desmos, graph it, and you can find the zeros that way. That's going to be the easiest way to at least double check your answers if you get hung up within the homework. All right, last but not least, there is one other form of factoring that they may ask you to do, and that's factoring by grouping. Grouping we're going to do when we have 4 terms. Greatest common factor we can always do, but you're typically going to be doing it with 2 terms. Doing this unfoil method is going to happen when you have 3 terms. We're going to factor by grouping when we have 4 terms. To factor by grouping, we factor these groups individually. So I'm going to break my problem into 2 groups. I've got group number 1 and group number 2 here. So this x cubed minus 2x squared, I'm going to factor this group first. Looking at this group, I can factor out an x squared, which leaves me with x minus 2. If I factor this 4x minus 8, I can factor out a 4, which leaves me with x minus 2. As long as these 2 things match up, the fact that I have an x minus 2 and an x minus 2, that's going to be one of my groups. That's one of my factors. The other factor is what we were able to factor out. That would be that x squared plus 4. So if we set those equal to 0, then x equals 2. X squared plus 4 equals 0. Subtract 4 from both sides. Square root. X equals plus or minus the square root of negative 4, which in this case is an imaginary solution, which we'll mess with later on, not so much in this unit. So the example I picked was probably not the best example, but you get the idea. I wanted to show you the example of the factoring. I should have picked one where I got all real solutions, but regardless, the steps are going to be the same. I do want to give you another example of that just so I can walk you through factoring by grouping, and this page is getting kind of crowded, so I'm just going to get a different piece of paper. Okay, so again, 4 terms. We're going to factor this by grouping. So I'm going to look at this first group, and then I'm going to look at this second group. So if I just look at the first group, I can factor out an x to the second power. If I divide that x to the second out, then I'm left with 6x minus 1. Looking at just this second group, that negative 96x plus 16, I can factor out a negative 16. Negative 96x divided by negative 16 is a positive 6x. Positive 16 divided by negative 16 is a negative 1. And again, this only works if what I have in parentheses is the same. So the previous problem, my x minus 2's were the same. In this particular problem, my 6x minus 1's are the same. So that represents one of the factors. The other is simply what I have factored out. So if 6x minus 1 is a factor, set that equal to 0, add 1 to both sides, divide by 6. I get a 0 of 1 over 6. If x squared minus 16 equals 0, add 16 to both sides. To get rid of the squared, we square root. Remember, anytime you square root something, you account for both the plus and the minus. Square root of 16 is 4. So that represents a plus or minus 4. That's not a 14, that's plus or minus. And basically what that's saying is positive 4 and negative 4. Which again, makes sense. If this is a cubic function, I should have 3 zeros. So I got 1 over 6, I got positive 4, and I got negative 4. And that's going to be the hardest part of this particular unit, but that's what 4.1 is basically about. The first part is a lot of definition stuff, leading coefficients, degrees, and then end behavior. From there, they're going to talk about zeros and multiplicity. What are the zeros? What are the maximum number? The hardest is whenever they specifically ask you, hey, here's a function, what are the zeros? And being able to find those. All right. Needed to look and make sure everything's good. Okay, I was just checking the chat and making sure there wasn't any questions I was missing. And again, I didn't hear anybody ask any questions. So, all right. We're going to go ahead and progress on. I got 10 after 8, so we're going to do 4.2. 4.2 really is just about matching graph behavior. So we're going to do a lot of that same stuff. So 4.2 is about graphs of polynomial functions. And really one of the biggest things, one of the biggest indicators of which graph you're going to choose. This is also, I'm going to show you, a lot of this is going to be examples that I'm going to show you from the study plan in the My Math Lab. So I'm going to hopefully share that screen. But the first thing we're going to look at is that end behavior. And end behavior in and of itself will allow you to, I don't know, at least knock out like half of the choices in terms of the graph. Okay, so remember, even powered functions, if it's a positive even powered function, your end behaviors are both going to go up. If you have a negative even powered or even degreed polynomial, then your two end behaviors are going to go down. A positive odd degreed polynomial is going to go down to the left, up to the right. A negative odd degreed polynomial is going to go up to the left and down to the right. So just knowing end behavior is going to get you quite a ways into this. The next thing I would particularly look at are these zeros. If we can find the zeros of the function, you can use those to match the function. Or if it's a matching thing, you can just plug in specific x and y Points. Another easy point to find is your y-intercept of the function. And if that doesn't work, then we're going to relate to just finding specific x and y values within the graph. So when given a function and a graph to match it, this is the order in which I'll probably look at specific things. First and foremost, end behavior. This is actually going to help you determine, it'll at least knock out 2 of the choices. Sometimes it'll even just give you the answer. So this is where we always want to start. Okay. Next, we'll look at the zeros. We'll look at the y-intercept of the function, and then we can find specific x and y coordinates. So we can just simply plug an x in and determine where my y would be. So again, on a graph, the horizontal axis is the x, the vertical axis is your y. So your zeros are where you're going to cross the x axis. Your y-intercept is where you would cross the y axis. And then if we want, we can find any x and y coordinate by simply plugging in an x coordinate, figuring out what that y value is, or plugging in that x coordinate, finding out what that y value is, and then we can match that way. So I'm going to pull up some problems from the study plan. We'll be able to walk through that, and I'll show you what I mean. So see if it didn't log me out. There we are. So again, under my math lab, come on, study plan, all chapters. I'm going to look at 4.2. There we go. All right, so if I share this screen, okay. Hopefully you're looking at a question here. It says 4.2 graphing polynomial functions. This is specifically 4.2.17, okay? And I'll zoom these graphs in so hopefully you can see, but okay, here's the function, f of x equals x to the 6th minus 4. So we're wanting to match this graph. And this particular function we can do just with end behavior. So again, the 4 things we would look at are, number 1, we would look at end behavior. Number 2, I would look at the zeros. Number 3, I would look for any y-intercepts, then I would do specific points. But in this case, if you look, your end behaviors are all different. So as long as we know the correct end behavior, we can figure it out. This x to the 6th is a positive, even polynomial. Okay, so again, just focus on the biggest power, positive, even polynomial. My end behaviors should both be going up. Here they're both down. Here's one up, one down, one down, one up. Okay, so in this case, B is going to be your correct choice. So just knowing your end behavior is enough to get you into the right choice with this particular one. Okay, so we clear our drawings out and we can click B. Oops. Click B. All right, and that's going to be the right function. Okay, here we go. This gave us a function, but it's actually written in that factored form. Okay, so we have an x minus 1, an x plus 1, and an x minus 6. So a couple of things we've got going on here. And I would look at end behavior first. So if we look, this has 1, 2, 3, 4 x's. There's no multiplicities within here. So this is an x to the 4th powered function. If we were to multiply this all out, we would end up with an x to the 4th power. So again, positive, even function. My end behaviors are both going to be facing up. So clearly not A, clearly not C, clearly not D. Because if you look at A, okay, you've got one down and one up. B, they're both facing up. C, they're both facing down. D, you've got one down and one up. So even just looking at your end behavior, clearly B is going to be the right choice. If you can't see that from the factored form, if what I just said made absolutely no sense, then we can actually go through and look at the zeros. So that is the next thing we would look at. So x minus 1, x plus 1, and x minus 6. So again, if you're looking at your factors, okay, then x equals 0 is going to be one of my zeros. X minus 1, so that means positive 1 is going to be your 0 because 1 minus 1 is 0. X plus 1, okay, negative 1 plus 1 is 0. X minus 6, all right, that means 6 is a 0. So I should have these 4 zeros. So if I zoom these graphs in, okay, I should have these 4 zeros. Well, this one clearly only has 1, 2, 3. It only has 3 zeros. It can't be that choice. And based off of the end behavior we already talked about, we know the right answer is going to be B. So I'm going to zoom B in. Oh, that's way better if I go to this and it'll actually blow the picture up. Okay. And then you can look 1, 2, 3, 4 zeros. It doesn't do a really good job of giving me my scale, but if you look, each of those is worth 2. So we've got zeros at negative 1, 0, positive 1, and positive 6. So that's all the same zeros. So that's going to be the correct choice. If we were to zoom in on C here, if I blow this one up, okay, looks like we've got negative 1, 0, positive 1, and 6, but my end behaviors are going in the wrong direction. So this one actually has the right zeros, but you do have to understand that your end behavior is going the wrong way. But B is the one that has the correct end behavior and has the correct zeros. There we go. Okay, again, gives me another function. So f of x equals 1/2 x to the 4th plus 2x cubed. So that 1/2 x to the 4th, the biggest degree. This is a positive even degreed polynomial. My end behaviors are both going to be facing up. So that means A is a possibility. That means B is a possibility, but not C. C's got one up and one down. D's got one down and one up. So those are not it. So now, again, end behavior knocked out 2 choices. So it's either going to be A or B. Okay, so the next thing I would specifically look at is the zeros. Now, if you aren't good with the factoring and finding these zeros, then what I would do, okay, again, if I can kind of zoom these graphs in so we can look. Okay, so choice A, we've got some points we can kind of plug in and double check what's going on here. Okay, this is one where I might actually pick an X and a Y and see if I can find the exact point. I want to see how this graph pairs with the other one though, but this one looks like, Okay, if we plug in the point, see, if that's -10, each of these represents -2. So if I plug in an x of -4, I should get a y of 0. If I plug in an x that's 0, I should get a y that's 0. And I can look to see if either of those points match. I want to see if that's different than the graph for B. Yeah. Okay. So if we look, this is graph B here. Okay. B gives us clearly different zeros, somewhere between 1 and 2, somewhere a little bigger than 4. Okay. Or we can check that y intercept. That's specifically the point that I'm going to look at because, okay, so the y intercept is again where we cross the y axis. For choice B, all right, my y-intercept is somewhere down here, okay? I don't know exactly what that point is because this represents 100 on the y. So this is probably what, every 20 then? So this is somewhere right around -15, 16, something like that. But anyway, this has a y-intercept somewhere down here, -10, -12. I don't know exactly what that is, but you're going to have some negative y-intercept. On the other hand, if I blow choice A back up, choice A has a y-intercept here, okay, at 0. So choice A has the y-intercept of 0. So if I can just find which one of those graphs is correct, I know which one the right answer is. So again, go back to my original function. Okay, f of x equals 1/2 x to the 4th plus 2x cubed. So again, to figure out which one of these is correct, I want to find that y-intercept, or what the y-intercept should be. The way we do that is we actually plug 0 in to the function. So I'm going to take 1/2 times 0 to the 4th power plus 2 times 0 to the 3rd. Okay, 0 to the 4th is 0, times 1/2 is 0. 0 to the 3rd is 0, 0 times 2 is 0. So everything cancels out. So this is actually going to equal 0. So if I plug in an x of 0, I get a y of 0, and then this is the correct function. So end behavior knocked out C and D. I can plug in specific coordinates, in this case the y-intercept, to figure out which of these is the right solution. B did not have the correct y-intercept, but A did. So A is going to be the correct choice. We'll do one more of these, and then there's one more thing I need to show you, and then we'll be done. All right, so this is another function. So f of x equals negative x to the 4th minus 5x to the 3rd. This is a really nice one because, again, we can just do this simply based off of end behavior. But if we've got this negative x to the 4th power, we have a negative even powered polynomial. So again, even means they're both going to go in the same direction. The fact that it's negative means my end behaviors are both going to go down. A shows up and down, not it. B shows both down, that's a possibility. C shows both up, not it. D, we've got a down and an up, not it. B is going to be the correct choice. Now, let's just, again, pretend, okay, maybe C has the right end behavior. Okay, again, one thing we could do is if I were looking specifically at B and C, All right, specifically, this is choice B. Sorry, there's something on my screen I gotta get rid of. Okay, again, if this is choice B, points I would pay attention to are here and here. And then maybe we could plug in one of these X's and we can find some, I don't know, some other point that looks like it would be good to try. But this one here stands out to me, plugging in X of 0. So this one has a Y-intercept. So choice B has a Y-intercept of 0. We also have a 0 over here somewhere at about -5-ish. I don't know if that's exactly right, but at -2, I would get a Y value somewhere up in here. And I could check any of those. So if I get out of this one, and if I blow up choice C, all right, unfortunately, C crosses in the two places, so it's going to have the same 0. So really the only way to differentiate between B and C would be based off of end behavior. Or, okay, at -2 here, choice A, okay, for choice B, I guess, remember if I plugged in this -2 for X, the graph was up here. For choice C, if we plug in this -2 for X, we got some value down here. So at X equals -2, choice B gave me a Y value of positive something, right around 4-ish, or no, probably about 40-ish. Whereas this one's gonna, if I plug in an X of -2, I'm gonna get some sort of negative value for Y. So if I close this out, go back to my initial function. Okay, so this negative x to the 4th minus 5x cubed, if I plug in a -2, then I can figure out exactly which y value corresponds to the correct one. So -2 to the 4th power is a positive 16. The negative of that is -16. Okay. -2 cubed is -8. -8 times -5 is positive 40. And then 40 minus 16 is a positive 24. So I had a positive y value if I plug in an x of -2. So again, B ends up being the right choice. So anyway, again, end behavior is going to get you most of the way. There's very few problems where you're going to need another coordinate, but you can always plug in various values of x and then figure out what the y value would be. The hardest problems in this particular section are going to be problems where you're not matching the graph. They actually give you a couple of functions where they just give you the function and they want you to graph it. I'm looking for a specific one. So what, I'm going to stop sharing, see if I can find the right problem. We'll go from there. All right. These are the hardest problems on this particular section. It's just going to give you a function like this, f of x equals -x cubed minus 6x squared, and it's going to tell you to graph this particular function. Again, one of the best tools you have for your homework is Desmos. If you go into Desmos, you can just type this particular function in, know exactly what it looks like, and then just try to match that graph. Now, also graphing within My math lab is a little bit tricky. One thing that will definitely help you out is you're going to want to click on this button here. If you just click on the graph, it will give you kind of an expanded view. Okay, and then you've got all your graphing buttons down here at the bottom. So we've got this arrow, we've got the straight line, we've got the absolute value, we've got the quadratic, we've got the cubic function. Okay, but this is still a very small graph. And then where you're putting your dots, it's kind of tough to tell exactly where you're at. Now, here, I need my pen, come on. Play nice. It does give you an indicator of the coordinate that you're on. So as you move within that graph, that number will change. Okay. So again, wherever you're at in the graph, notice how that coordinate changes. So that's going to be helpful. But really, this is much easier if you click on that box. If you click on that box, it blows things up, and then it does the same thing. But to me, it's easier to see. Okay, it's going to your coordinate's going to be up there in that section. So again, wherever you're at, that gives you the coordinate location. To me, it blows it up a little better. All right, so again, with this particular function, we're going to be graphing negative x cubed minus 6x squared. Okay, this is going to be extremely important. Number one, you have to know what the graph is even going to look like. The fact that this is a third power tells you it's a cubic function. Your graph is going to look kind of like so. Okay, it's not linear. It's not an absolute value. It's not a quadratic parabola. It's going to be this S-shaped looking graph. So that's the one that we've got to make sure we pick, this particular shape here. We're not graphing a circle or a straight line. We're graphing this kind of S shape. The fact that it's negative tells me that that's going to flip over actually. We're going to go in this direction. So that's what we're going to be graphing. Now, on my math lab, specifically whenever you graph, it is extremely important that you kind of graph. You don't have to graph it necessarily in order, but in order to get your curves, you've got to graph points kind of along those lines. You can't graph all of your points over here on this side. It doesn't know where to draw the whole curve. You're going to kind of need to graph your points throughout. So what I mean by that is, okay, again, f of x equals negative x cubed minus 6x squared. We need to know where our zeros are. If we don't know where our zeros are, we're going to have a very hard time graphing this. It's not going to look right. So again, you can use Desmos to check that out. In this case, we're going to factor by graphing. We're going to find my zeros by factoring. If I factor out an x squared, that leaves me with negative x minus 6. So that means my x's or my zeros are going to be at 0. It's a 0. So 6, so x is going to equal negative 6. So my zeros are going to be at 0 and at negative 6. So I know I'm going to need to plot those 2 points. And again, knowing that this is a negative cubic graph tells me my graph is going to go in this direction. Okay, that tells me I'm going to graph it like so. I'm going to curve around like that, and I'm actually going to bounce because at this negative or at the 0, that's my multiplicity. So my graph is going to bounce kind of like that. So I need to find specific points. So I already know my zeros. I'm going to plot those. I need to plot some point over here, and I need to plot some point over here. So I'm going to need very specific coordinates. So again, I'm going to pick one of these x coordinates. Doesn't really matter which one, but let's say I want to use -1 just because -1 is going to be a smaller number to mess with. So if I plug in an x value of -1, okay, -1 to the third power is -1. The negative of -1 is going to be +1. -1 squared is 1. -6 times 1 is -6. 1 minus 6 is -5. So that gives me the coordinate -1, -5, meaning if I plug in an x of -1, my y value is going to be -5. So I need to plot that point. So my zeros, and then my coordinate -1, -5. Okay, same thing. I need a point over here. I'm going to pick an x value of 2. If I plug 2 in, then -2 cubed minus 6 times 2 squared. 2 cubed is 8. Negative of that is -8. 2 squared is 4. -6 times 4 is -24. -8 and -24 is a -32. So if I plug in a +2 for my x, I'm going to get a -32 for my y. So these are the 4 points that I'm going to need to plot to make sure my graph actually goes where it's supposed to. So again, on my tool, I'm going to pick the cubic tool. Okay, hopefully you can see that hand. I'm going to pick this tool, and I've got to plot my points at -0, -6, 0. Come on. Sorry, I'm going to plot my points at -6, 0, 0, 0. All right, at -1, -5, and then at +2, -32. Clear my drawings out of the way. So again, just to kind of walk through exactly what I did. So that -x cubed minus 6x squared, we found my zeros at -6 and at 0. That's why I plotted those 2 points. I needed to find 2 others to make sure my curve was right, so I just picked a point in between. I picked that x value of -1, plugged that into my function, which gave me a y of -5, which is why I graphed that point. Then I picked an x value of +2, just because, plugged that into the function, and got a y value of -32. That's why I graphed that point. My math lab went ahead and drew this whole yellow curve in. So then I can save this, and then I can check my answer. All right, we'll do another one of those. Again, this is the hardest one. And really, as far as what I think is important in terms of this class is not going to be specifically just graphing. It's more about finding the zeros and then knowing your end behavior. So it'll largely be along the lines of the matching style of problems. I'm just kind of trying to help you out with what my math lab is going to require of you. Uh-oh. Stopped sharing. I didn't mean to stop sharing. All right, pardon me. Got a bad screen. I'm going to come back to that. Give me 1 second. Sorry. Again, my window closed. I'm trying to open my window. I don't mean to not be talking. We're not just silent here. All right, so I went into my math lab. I'm opening 4.2 again. I want to do one more graphing example. Hopefully I get the right one, then I'll share my screen again. Okay, here we go. So if I open my Zoom back up, screen share, come back, got it. All right, so again, hopefully we're all on the same page. But it's asking me to graph this particular function. So h of x doesn't matter. I'm going to do it for f of x. F of x equals x squared plus 4x minus 5. Okay, again, extremely important to know the specific shape of the graph we are talking about, because whenever you go to graph it or you click, you're going to need to know the basic shape before we start. This is the graph for a cubic function. Okay, this particular function is, get my pen right. Okay, this is a power of 2. This is a quadratic. Quadratic functions graph in the shape of a parabola. We're going to make sure we click on the parabola. For the parabola, we're going to need to find 3 specific points. It's going to be easy in this case probably to find the zeros and then go from there. So x squared is a parabola. Make sure you pick the quadratic. So step 1, make sure you have the correct shape down. Anyway, x squared plus 4x minus 5. I want to find my zeros. This one factors really nicely. Again, I'm looking for numbers that are going to multiply to get -5, that are also going to add to get +4. The only numbers that multiply to get 5 are 1 and 5. In fact, this is negative, tells me one of these needs to be negative. And -1 plus 5 does give me +4. So there's my factors, which means if x minus 1 is a factor, then +1 is my 0. If x plus 5 is a factor, then -5 is a 0. So at +1 and at -5 is where my zeros are going to happen. So I'm going to need to plot those 2 points specifically. Then I just simply need a third point. And the good thing about a parabola is it doesn't matter if it's over here to the left or if it's in between or if it's over here to the right. You can pick any x and y coordinate, or really any x, to figure the correct y coordinate. So I'm going to pick something easy. And in this case, the y-intercept is going to be very easy to find. So if I make my x value 0, meaning if I plug 0 in for x, then 0 squared plus 4 times 0 minus 5 is 0 plus 0 minus 5. So if I plug in 0 for x, my y is going to be -5. So down here. This is the 3 points I'm going to plot. My 0 at 1, my 0 at -5, and then the specific coordinate 0, -5. This is my y-intercept. So if I plot those specific points, again, enlarge my graph. Oh, all my drawings are in the way. Let me clear those out. If I clear my drawings. Okay, again, it's important to remember the shape. So if I'm annotating here, remember this is a quadratic, so I need to click on the parabola button. When I do, it's going to ask me to find 3 points. My zeros were at -5, and +1, if I remember right, yeah. Okay, so that's where I'm going to plot my points. Also, if we plugged in 0, we got the point 0, -5. So those are the 3 that I'm going to mark. So if I click on the parabola, it's going to ask me to plug in the point. And again, if you look in this area, that tells you specifically which coordinate I've highlighted. So if I want to plot the point -5, 0, I'm going to go there and draw one of my dots. Okay, at +1, 0, and then at 0, -5. And then it graphs the yellow line, which is what I want. Save, check my answer. All right, and again, always remember that you can use Desmos to check. So if I share my screen, whoops, stop share, I want to get out of that one. Share my screen. Yeah, here we go. This particular one. Again, Desmos, DES, MOS. Go to your graphing calculator. You can type in whatever the heck you want and it'll graph it for you, and then you can use that to make sure you've got the correct answer. Come on, internet, play nice. All right, so if I go to Desmos, the last function we did was x squared plus 4x minus 5. And again, exact same graph. My zeros were at -5 and 1. If I want to check my y-intercept, it was here at 0, -5. You could have plugged in any of these other points like -2, -9, or anyway, I was trying to pull up the coordinate there. It's not staying very well. So about -4, -5. Okay, you could plug in that specific point. So you could plug in any of these other coordinates. And it doesn't matter what the function is. If it would have been x cubed, okay, minus 3x plus, actually let's just do minus 3x. Okay, then you could have graphed these specific points. You can always use Desmos to check any of your graphs, and then you could plug that in. All right, hopefully we'll be back in class next Thursday, but that's all I've got for you guys. If there are any questions, ask them. I'm going to embed this recording in Canvas. So if you guys don't have anything for me, we'll just sign off and call it good. Hope you guys are able to follow that. Have a good evening.